On the following, it's asking you, is the relation a function? Remember, if the relation, that means that your x and y values have to be 1 to 1. That means that for every x, there has to be a y value. For every x, there has to be a y value. So if I go to every x, it can only produce one y value. So for this x, there's only one value. For this x, there's only one y value. For this x, there's only one y value. And if you notice, for each of the x's, there's only one y value. For this x, there's only one y value. One y value, 1 and 1. So this is the relation is a function. And to explain it, you can just write down, yes, since every x produces only one y value. On the next one, is the inverse a function? For the inverse, since to be able to find the inverse, the x's and the y switch. The y becomes an x, the x becomes a y. So therefore, instead of looking at the x values, we're going to be looking at the y values, and they should only produce one x value. So we're going to go left and right. So for every y, there should only be one x. For every y, there should only be one x. For every y, there should be one x. For every y, should be one x. Yes. So for every y, there's only one x value. So this is also a yes. The inverse is also a function. And just write the same process. Since the inverse switches the y to an x and x to a y, then the y's can only produce one x value. Any type of explanation, something close to explaining the x's can only produce one value, and for the inverse, the y's can only produce one x value, should be sufficient.